In section 2 of factoring here, we're going to look at factoring trinomials, both with a equal to 1 and then with a not equal to 1. When we talk about quadratics in a trinomial, we kind of say the general form for these is ax squared plus bx plus c. So we need to know what a, b, and c are, and we'll deal with these when we get into our quadratics units as well. But a is always what's in front of x squared, the number in front of x squared. B is always what's in front of x to the first power, and c is our number term or our constant term it's called. Okay, so we're going to look at number 3 here, factoring the trinomial x squared plus 4x minus 1. This kind of factoring is opposite of foiling two binomials together or multiplying two binomials together. So our answers are going to end up being a binomial times a binomial. Okay, so the rule is, and we call this AC factoring, because you want to multiply a times c in each case. So if I look at number 3 here, a is 1 because it's 1x squared. So when a is 1, I'm going to take 1 times c. So 1 times negative 21, which is negative 21. So I'm going to write down p for product. When I did a times c, I got negative 21. Again, because the 21 has a minus sign in front of it, 1 times negative 21. And then I want to do a sum of what b is. So the sum has to be what b is, or what's in front of x. In this case, there is a 4. So what I want to do is I want to list pairs of factors of negative 21, or that have a product of negative 21. Now, to get a negative product, we have to multiply a positive times a negative. So I could do 1 and negative 21. Okay, 2 doesn't go into it. I could do 3 and negative 7 would be a product of negative 21. And then 4 doesn't and 5 doesn't. So those are the only pairs, 1 and 21 and 3 and 7 if we think about factors of 21. But we're trying to get a negative 21. So now I could flip-flop signs and say, well, 7 and negative 3. And also 21 and negative 1. So when the product is negative, we want to look at that. Now, we're trying to look for a pair of factors of negative 21 that have a sum of positive 4. Well, if I look at my first pair here, which are 1 and negative 21, they add to negative 20. If I look at my second pair, 3 and negative 7, they add to negative 4, have a sum of negative 4. But if I look at this pair right here, 7 and negative 3, they have a product of negative 21 and a sum of 4. So that's my pair of factors I want to pick. So what you're going to do is you're going to change this into a grouping problem. You're going to split the middle x term. So I have x squared plus 4x minus 21. What we're going to do is we're going to keep the x squared, we're going to keep the minus 21, and we're going to split this 4x into x terms that have those pair that I need, which is the 7 and negative 3. So I'm going to go plus 7x and minus 3x. Because if I combine those, that would give me the 4x. And now you want to turn it into a factoring by grouping. Because now I've created 4 terms by splitting that 4x into 7x and negative 3x. So I want to group here, just like we learned in the first section. I'm going to group those two together. Now you really have to be careful when this is a negative. We're going to group that negative 3x minus 21 together. Here I'm going to be able to take out an x from x squared plus 7x, and I'm left with x plus 7. And over here, when I have the negative 3x minus 21, I actually want to take out a negative 3 from those two terms. And when I do that, I take negative 3 out, I'm left with x. And when I factor the negative out of this minus 21, that's going to change that to a positive. And then 3 times 7 would give me the 21. And then I want to look at, I have the x plus 7. So remember what we did in the last section. It ended up being two binomials when we did factoring by grouping. So it's x plus 7 and x minus 3. Now the shortcut was we really ended up in the binomials with those two terms. That only works when a is 1. I wanted to show you the grouping method because when a is not equal to 1 in section B, we're going to have to do it by grouping.